Hi, today we discuss about chromatography. It is a separation technique as well as an identification technique. The basic principle involved in all the chromatography is the involvement of two phases called a stationary phase as well as a mobile phase. A stationary phase is fixed in certain surfaces, while the mobile phase can travel over the stationary phase. Usually the mobile phase carries the components to be separated or identified, and they move over the stationary phase. And now we discuss about the classification of chromatography. We can have various way of classifying the chromatography. One is based on mechanism of separation. For all the chromatography technique, there will be a mechanism of separation between the components. If the separation is based on adsorption, you know what is adsorption, then it is called adsorption chromatography. If the mechanism of separation is partition, and it is called partition chromatography. We'll discuss the term partition later. Now next is based on phases. There are two phases called stationary phase and mobile phase. So we discuss based on, or we classify based on their physical state. The one is called a solid liquid chromatography. Solid liquid chromatography means here the mobile phase is a liquid while the stationary phase is a solid. So it is called a solid liquid chromatography. Now if the mobile phase is a gas and the stationary phase is a solid, then it is called a gas solid chromatography. Now you have liquid phase chromatography. There you have liquid chromatography. Both the components, both the phases, mobile phase as well as the stationary phase are liquid, hence it is called a liquid chromatography. Now you have the mobile phase as gas while the stationary phase as liquid, then it is called a gas liquid chromatography. While you are saying, first you have to specify the mobile phase, then the stationary phase, but here it is given in an invert way. First it is given as stationary phase, but actually you have to give first as the mobile phase, then the stationary phase. Then it is based on the shape of chromatography, but of the basis of the technique of separation. Now you can also call it as technique of separation. Now actually you are preparing a chromatographic bed, or we are preparing a stationary phase. Based on that we can have a planar chromatography. In planar chromatography what you are doing is the stationary phase is prepared in a plate. It will be a glass plate, it will be a thin metallic plate, or it will be a paper, like that. Over that you are preparing the stationary phase in a planar manner. That's why this chromatography is called a planar chromatography. Now you have column chromatography. Here what happened? The stationary phase is prepared in a column manner, long column. That's why it is called a column chromatography. Now we start with the column chromatography. So we can have different types of column chromatography. The first one is called what do you mean by column chromatography? The stationary phase is prepared in a column manner. So you can see here, this is the stationary phase which is prepared in a column manner. That's why it is called a column chromatography. Here we'll discuss first the adsorption column chromatography. Why it is called adsorption column chromatography? The stationary phase is prepared in a column manner while the mechanism of separation is adsorption. That's why it is called adsorption column chromatography. It belongs to the class of liquid solid adsorption chromatography, which means the mobile phase is a liquid while stationary phase is a solid. So let us start discussing about adsorption column chromatography. First of all, we have to prepare the stationary phase. The stationary phase is prepared as a long column manner in a what is so called maybe a glass tube, or you are familiar with the burette like that. Usually the stationary phase is either silica or alumina. Silica, gel or alumina is taken as the stationary phase. So here you can see the blue line or blue shaded area is the stationary phase. Now we have the components to be separated. Let us say the components are X and Y. The components are taken along with a solvent. So what happens? The solvent will contains the components to be separated is called the mobile phase. So here you have the solvent, then here you have a mixture containing the components X and Y. Now what happened? These together called the mobile phase. Now while the mobile phase travels over the stationary phase, what happens is the different components will have different rates of adsorption. So if there are more adsorption, they easily get adsorbed. So here let us say the component X having higher rate of adsorption, so it will first get adsorbed on the stationary phase. So here you have X, while at the bottom you have what is so called the next component Y. So here the two components X and Y get separated. So X is at the top because it is having higher adsorption, while Y is having lesser rate of adsorption. So the components get separated. It is based on the mechanism of adsorption, or you can say it is based on differential rates of adsorption. Different components have different rates of adsorption. That's why they get separated. Now once the components are adsorbed or separated over the stationary phase, now what we have to do is we have to separate the adsorbed components. Here you can see the component X is adsorbed over the stationary phase. Now we have to remove this component X from the stationary phase. So how it is possible? What you have to do is, now you have to remove this solvent and you have to take another solvent. In that solvent only this X get dissolved. Only X get dissolved, and you have to pass that solvent through this column. What happens? The adsorbed component X get dissolved in that particular solvent, while Y will not get dissolved. And the solvent which you use for separating the individual component is called eluent. E-L-U-E-N-T, eluent. And the process of separating the adsorbed component is known as elution. So similarly you have to pass another solvent in which only the Y get dissolved. So again you have to take another solvent, you pass it so that the Y also get dissolved in that solvent, only Y. So that process is known as elution, and the solvent used is called eluent. So that's about what is called the adsorption column chromatography. Now let us start discussing about partition law. We'll have a quick look over the partition law. It's also called a distribution law. Then we discuss what is called the chromatography technique based on partition. The partition law is very simple. You have two solvents here. They are A and B, and they are immiscible with each other, just like oil and water. So what you have? You have a solute X. Solute X is actually common to both the solvent. What do you mean by that? The solute can soluble in both the solvent A as well as B. So initially, if the solute is dissolved in the solvent A After some time, the solute will passes into the next solvent B also. Then there reaches an equilibrium between the concentration of the solute in solvent A as well as the concentration of solute X in the solvent B. And that ratio, concentration of the solute X in solvent A divided by concentration of the solute in solvent B, will be a constant. Now this constant is called a partition coefficient. So this is partition law or distribution law. In a very simple manner, the two immiscible solvents are in mutual contact with each other. So what happens whenever a solute X is common in both the solvent, which is initially present in one of the solvent, will get partitioned or distributed in both the solvent, and the ratio of their concentration will be a constant. Now let me introduce a term called a partition coefficient, which is K, the same constant. Partition coefficient, here I given it is equal to Cs divided by Cl. What is Cs? It is concentration of solute in stationary phase divided by concentration of the solute in mobile phase, because we are applying this partition law to our chromatography where you have the stationary phase and mobile phase. So we will discuss Cs as a concentration of the component in stationary phase and concentration of the component to be separated in mobile phase. That ratio is known as partition coefficient. Look, if greater is the partition coefficient, what's the meaning? The particle or the component to be separated is more on the stationary phase. Clear? So greater the value of partition coefficient, the particles are get retarded or remain with the stationary phase for some more time. So that is the partition coefficient.